Meet Alex, Sam, and contractor Dan. They need to collaborate in a shared project folder, but standard Unix permissions only recognize owner, group, and other, and that trio breaks down fast. Putting Dan in the developers group overgrants him write access, while opening permissions to other exposes the folder to every account on the system. A single group simply cannot capture the messy reality of modern team membership. POSIX ACLs solve this by extending the UGO model with additional permission entries. One per named user, one per named group. Instead of 3 rigid slots, a file's ACL becomes an extended list of entries that the kernel checks in order. You can now grant Dan read-only access as a specific individual, without touching the developer's group, and without leaking access to other. There are 2 flavors of ACL, and the distinction matters. An access ACL sits on a specific file or directory and governs only that object. A default ACL, on the other hand, can only live on a directory. It acts as a template that automatically copies itself onto any new file or subdirectory created inside. New files inherit the template the moment they appear. Every ACL entry follows a strict type tag format. The 4 entry types are U. Name for a named user, G. Name for a named group, M. For the mask, and O. For other. Concrete examples. U Dan, R, grants Dan read-only G design. RW, grants the design group read-write M. RWX sets the mask ceiling, and O, R, sets the fallback for everyone not explicitly listed. The mask is the effective write ceiling, the most important concept in the entire ACL system. Any permission granted to a named user, a named group, or the owning group is intersected with the mask before the kernel enforces it. Requested writes intersected with the mask equals effective writes. If you grant Dan RW, but the mask is R, Dan only gets read. When a file carries any ACL entry beyond the basic UGO set, ls, L reveals it with a single trailing plus sign in the permission string. RWRR, plus instead of RWRR. That plus is the kernel telling you the listing is incomplete, and you need getfacl to see the full picture. Before ACLs, no plus. After ACLs, plus appears and the real permissions are waiting behind the curtain. Access control lists extend the standard Linux permission model, letting you grant access to specific users without changing file ownership or group membership. In this demonstration, we'll create a file, inspect its default permissions, then use setfacl to grant a named user read access and verify the change. We begin with a clean workspace using clear. This isn't strictly required, but it keeps our session tidy and makes the subsequent screenshots easier to read and follow. Next we create an empty file called acldemo.txt and /tmp using touch. This gives us a clean target file with default permissions to work with throughout the demonstration. Now we inspect the file with ls, L to see its default permissions and ownership. Right now, only the file's owner has write access. The standard Linux permission triplet is in effect, with no ACL extensions yet. Before modifying anything, we run getfacl to capture the baseline ACL. This shows the file owner, owning group, and the standard user, group, and other entries, exactly what you'd expect from a file without extended ACLs.